Hello everyone, welcome to this lesson. So in this lesson, I want to show you that the Gauss elimination code that we have developed in the previous lesson is actually a general code. You can actually use it to solve any size system of equation, just as long as the number of equations is equal to the number of elements that you are trying to find. In this lesson, I'm going to show you that the code can apply very simply to a 4x4 matrix or a system of 4 equations and also a system of 5 equations. So let's actually begin. So here's the system of 4 equations that we have. So you can see the elements that we're after, x1 all the way to x4, and here I have created the augmented matrix of the coefficients on the left hand side. As you can see, for the first equation we have 1, 2, -1, and 1. Second one here, -1, 1, 2, and -1. Third one, 2, -1, 2, 2. And of course, the fourth one here is 1, 1, -1, and 2. And here's the b vector, which is all the numbers on the right hand side here. So 6, 3, 14, and 8. Now, when we solve this system of equation, we should expect that the x values, x1 all the way to x4, would be 1, 2, 3, and 4. So these are the solutions for this system of equation. As I mentioned in the previous lesson, the only two changes that you need to make into this code is actually inputting this system of equations, which is made up of the augmented matrix A and the vector B. So the only two things that we're going to be changing in this code are the A and B. So let's actually see. So as you can see, where we create a matrix within Python, we use the array keyword, and it's the list of lists. And the lists here are the coefficients of each one of the rows. As you can see, the first element here is a list of coefficients on the first equation here. The second element, coefficients of the second row. Third element, coefficients of the third row. Fourth element is a list of the coefficients of the fourth row here. And you can see B is just merely a vector of the 4 values we have on the right hand side. 6, 3, 14, and 8. And those are the only two changes that you need to make in this code. As I've mentioned, this code is defined in terms of n, and n is basically the number of equations that you are interested in solving. And you can see n here is defined in terms of b, so that's going to be 4, and basically this is basically gonna go and solve a system of 4 equations. So actually, let's run this code. So I'm gonna run here before I begin, import numpy and also the array function in zeros. And if I run this, all right, perfect. So you can see here, the solution of this system is 1, 2, 3, and 4, as we have predicted here. So very simple. All you need to do is input the augmented matrix A and also define the matrix B. So let's actually move on to a larger system of equations. So a 5x5. So this system of equation, I actually got it because I want you to see that most systems of equations that you might be dealing with, they're not as clean as here. Here you have coefficients for all the elements that you're trying to solve, x1 all the way to x4. And also here you're dealing with integers. But in some systems, that's not the case. As you can see here, if we look at the first two equations here, we have only the coefficients for x1 and x2, and the coefficients for x3, x4, and x5, you can see all of them are zeros. For the third equation here, we have coefficients for x1 and x2 and x3, but zeros for x4 and x5. And fourth one here, you can see we have one for x1 and x2 and x4, but none for x3 and x5. And finally, the fifth equation here, we have a coefficient for x1 and x2 and x5. So usually when you are creating coefficients for this type of matrix, the elements that don't exist, of course, will have a coefficient of 0. And you can see everything on the right-hand side is defined as the b vector. Much like I mentioned, the only two differences that you need to make to the code is just input this augmented matrix A and vector B, as you can see here. So since we're dealing with 5 different rows here, we're gonna have 5 different lists. Each list is going to be corresponding to the coefficients of that particular row. So here we have the coefficients of the first row, comma, 5 coefficients of the second row, comma, 5 coefficients of the third row, and here 5 coefficients of the fourth, and 5 coefficients of the fifth. So this is the inputting of A, and of course the inputting of B is going to be a list of 5 values that we have on the right hand side here. Again, that's the only change that you need to make to this code. And here, these are the solutions for x1 all the way to x5. So if I run this code, if it runs successfully, these are the solutions I should expect out of the code. So if I run, you can see, okay, so the solution of the system, we have 1, 2, 3, 4, 5. So 5 different solutions, as you can see. 753.54, you can see here, 48, negative 741, 48, negative 741, 203 and 1148. You have 203 and 1148. So you can apply this to, again, any size system of equations, system of 6 equations, 7, 8, 10, however big the system might be. The only thing that you need to make sure is you have the same number of equations as you have the same number of unknowns. Here we have 5 different unknowns from x1 all the way to x5, so we have also 5 different equations. So that's the only way you can actually solve for these unknowns. So that's it for this lesson. So in this lesson, you have learned how to use this code in a general way. All you need to do is input A and B. In the next lesson, I'm going to show you that there are some systems of equations that you have to kind of manipulate a little bit for Gauss elimination to work successfully. So in the next lesson, I'm going to be introducing a technique called pivoting. But that's it for this lesson, and I will see you in the next lecture. Thank you very much.